Okay, welcome back. You just watched a video and you did an activity that actually looked at a real life situation where there was a predator and a prey interacting with each other on an island that humans, for the most part, don't really touch. Isle Royale up in Michigan. So there was a lot of data that you had to record. I'm sorry, it's just the way it is, though. Welcome to science. Most of this class, guys, might be a lot of definitions to start, but it's going to be a lot of looking at data and being able to analyze graphs. That is the most important thing, especially right now, man, since everybody's learning so much new stuff about the virus. Just being able to read graphs and know that they, knowing how to read them and look at them and interpret them and understand it. So that's kind of what we're getting into here. So let's say that stink bug from the previous activity, I know I talked about this earlier, comes back right here at this point in time. See the time on the x-axis? At this point in time, so let's say we've got, I don't know, 1900. We've got, this is 2020 right here. In 2010 right here, we'll say this is 2010, okay? The stink bug right here, predict what you think will happen to this population if the stink bug is introduced right here, okay? First off, what do you think is gonna happen to the stink bug population at that point right there? Comes in and there's plenty of plantains and berries. What do you think is gonna happen? What's gonna happen to the population if I were to draw a line? It's gonna go flat like that. It's gonna go maybe like a line like that. Or do you think it's gonna go like that? What do you think? Well, it's probably gonna go up, right? Because there's plenty of resources. Now, I don't know if it's gonna like just go steady like that or if it's gonna go up. So let's just do a small increase. We can make a prediction. If this starts to go up, make it a little bit more drastic. If this starts to go up, what does that mean about the berry population? Is the berry population going to go up or down? It's going to go down because there's more things eating it, right? That makes logical sense. Plantains as well, right? So the plantain population is going to go down. Well, if we're looking at the ladybird, or I'm sorry, the green fly, which is the prey, if the berries go down, what can you infer is going to happen to the green fly population, especially if green flies, butterflies, these birds here, and these grasshoppers all eat berries? What's going to happen to this green fly population in the orange? Is it going to just keep going on its normal track like this forever and ever? No. We're now competing at a more dangerous level, right? So you might see a decrease in the maximum population. You might even see it teeter out over time, maybe even hit zero if it goes kaput in this specific population. Okay, so according to this logic, if the ladybird, from what I'm seeing, only eats green flies, what's going to happen to the ladybird population? I'm going to change color here to blue. Is it going to continue just to go like this, honky-dory, happy day? No. It's got less food now because these dumb stink bugs are coming in. So you might see a decrease in population. They may stabilize at a lower population number, or they could just crash and burn into the ground, which is an awful thing, right? Because then if you take out the ladybird, what else gets affected? Take a look here. What gets affected? Easy, right? You show where the energy moves. So the bird and the dragonfly would get affected. And if the what's the name of this bird? It's called a bird. If the bird gets affected and the dragonfly get affected, everything else gets impacted, guys. This is why one species that isn't supposed to be there could wreck a whole entire ecosystem. That's why you got people freaking out saying like humans come in and they destroy everything. Well, yeah, it kind of makes sense, right? Because we level an entire playing field and we say, all right, well, it's you versus us, and mankind, we're just going to level everything. We're going to lay some concrete, and all of this life just goes out the window. Ecologically, that is an awful thing. But that's why there are preservations, where areas are conservation areas where life can't be touched by, infrastructure. We can't come in and just start building McDonald's everywhere so you can get your McChicken for $1. So that's why having a stable ecosystem with a lot of different species is important. Okay. Also, having many other species here is very important because if let's say like if the butterfly starts struggling, are the frogs going to completely go extinct? Not necessarily, because the frogs have dragonflies, grasshoppers, other sources of food, right? But the ladybird, the ladybug right here, the ladybug lost the green fly. According to this chart right here, it loses its only source of food. The only thing that this ladybug here, I don't know why it's called a ladybird, the only thing that this thing eats in this ecosystem is the green fly. If this thing goes kaput, this ladybug is screwed. Make sense? So having a diverse amount of life in an ecosystem is very important. Let us keep moving on. So all of these organisms, actually, how much time are we at? I can't even tell. I don't even know where to look because I don't know how to use this thing that well yet. But we'll stop right here. Take a breather. Come hang out with me live, and then we'll continue in a minute.